Right, so today's topic is about geometry. Now, the geometry in middle school, it covers plane geometry, Pythagorean theory, and triangles, polygons, rectangles, circles, and their relationship. And then 3D geometry, basically the prism in a box, right? Rectangular boxes, cylinders, spheres. Those are the main topics we should know how to do it. Okay. The very first important theorem is the Pythagorean theory. Okay. That was everybody knows that. The question is, how do you find special right triangles A, B, and C? Every A squared plus B squared equals C squared. That's very important formula. For the circle, we should know the couple properties. One is if you have a tangent line to the circle, and then this must be right angle. Okay. From the center to the tangent point. Another important property is if you have a fixed 2A and B, then doesn't matter where you move the point, the angles, those two angles must be the same. Okay, not only equal the same, not only equal, this is the center. Okay, C is the center. They're equal to half of theta. Okay, this is another important point. So the special case is if the triangle is inscribed is one side is on the diagonal on the diameter, then this is the center. Then this must be the right angle because it's going to be half of the 180 degrees, so it must be right angle. Doesn't matter where the point. Okay. I think those are the important properties. Others are just formulas, how to find the area or surface area of sphere. Okay, so let's talk about let's take a look at the example first. Okay, so an equilateral triangle with a side length of 2 units has a circular arc centered B. Okay, so this is a triangle. This is equilateral triangle. Okay, and B is the center. Okay. Okay, this is A and the C. Okay, so this is equilateral triangle. Equilateral triangle. Okay, and side length is going to be it's A. Okay, and A equals 2. All right. Okay, so I draw the circle here. Then you get 2 intersection points. So this will be D and E. Find the length D and E. Okay, clear? Yeah. So D and E parallel to A and C, right? From the picture, you can tell that. Right. So how do you solve this type of problem? This is you have to draw. Actually it's not that difficult. Okay, you need to draw important lines connecting some special points. Okay, then you probably can see how to solve the problem. Okay, so when you give a geometry problem, right, you're not given all the line segments you need to solve the problem. So when you look at this picture, the first thing to do is connect the important points. The center is the important point. tangent point is also important. So you connect it. Okay, then you get several right triangles. Okay, you get several right triangles. Okay, so this is F. Okay, this would be right triangle because it's tangent point. Okay, so then immediately you can get the length BF because this is a right. You see, this is a special triangle, right? This is a special triangle. This is a B, that's a C, that's F, right? And this side is 2. The other side, this is 30-degree angle, right? 60-degree, right? So this will be square root 3 over 2 times 2, okay? So that is going to be square root 3. So now you get the B and F. So you do some calculation first. Do some calculation first. So DE, okay? Yeah. You want to find out DE, right? Yeah. But DE, so what does BF tells you? BF is actually the radius. This is going to be the radius of the circle. Okay, right? If you, that's the radius of the circle. Then the problem is solved. Why? Can you see that? Yeah, anyway, if you get answers, show me that, okay? I did a half of the problem. Not much, yeah, there's not much computation here. Can you see that? Benjamin? Okay. But you have to see that the triangle BDE is also equilateral. Okay, if you know that, then I think this is obvious too, right? Then DE equals BD equals BE, right? All the sides, but this is a BD, DE, those are the radius. So you already know the radius, so that's a good square root. Okay. Then, yes. It's not a square root, square root 3, yes. Okay, so that's the easy way to solve the problem. Okay. Okay. All right. So now our next problem, we're going to apply the Pythagorean theory to solve the problem. We have the right triangle. Okay. This is A, B, and C. This is the right triangle. Okay. This side is 15, the other side is 39. Okay. And I draw the line from here to D. What I given here is I know I look at AD, that's going to be DC plus 9. Okay. I try to find out B and D, all the information. Find the unknown information. Yeah, find the AD, okay, and find the AD, find the DC, find the VD. Okay, all the unknown lines. Right, to solve this problem, I'm going to name the variables because I don't need to draw additional lines here. all I have to do is find the right triangle, applying the Pythagorean theory to this problem. Okay, so I'm going to call it the DC, here's a Y, and the BD called X, and AD is called Z. I think I'm going to find the BD first, okay? BC, okay, BC is the square root of 39 squared minus 15 squared. And after simplifying, it's going to be 36. Okay, so that's a quick one to do. So you already know that. Then you write down all the apply the Pythagorean theory again the other side. Okay, we do some preparation. So write down the formula. So x plus y equals 36. Okay, z equals y plus 9. All right, now we have to apply another formula. We have three variables here, right? The other one is going to be z squared equals 15 squared plus x squared. So it becomes an algebraic problem. The geometry problem is converted to algebraic problem. Now, I wanted to find x, y, z. Okay, can you do that? and if you get it, then show me, okay? So those are another linear, one of them is not a linear equation, so be careful. Okay, can you solve this? All right, anyone can solve the question? Okay, you must get the equation in one variable at the end, right? So you look at the last equation, z squared equals 15 squared plus x squared. So if you can express z in terms of y, x in terms of y, you can solve the problem, right? So this is okay. So x is going to be 36 minus y, right? And this is the same, right? So you get y minus 9 squared equals 15 squared plus 36 minus y squared. So then you solve for y, right? Right? Then you solve for y. All right. So let's try, right? Y squared, 18y plus 9 squared. And here's 15 squared, 36 squared minus 7, the double at 72y, right? Plus y squared. So y squared is gone. Right? Then you move this term to the left-hand side. So plus 18, 90y equals 15 squared plus 36 squared minus 9 squared. Then you solve it. And let's finish the computation. Right, y is going to be, let's try, okay, 15 times 15 plus 36 times 36 and minus 9. That's 9 divided by 90, so it's 16. Okay. So once you get 16, then you get x, right? X is going to 36 minus y, so 16. Okay, that's going to be 20. Okay, then you can get a z. Okay, z is not a ratio. Z is not an integer probably, right? Z is going to square 15 squared plus x squared. So 15 squared plus 20 squared. Let's see. Maybe it's also integer. Yeah, it looks like it. You know, you don't even multiply this out. So 3 times 5, and here's 4 times 5 squared. So there's a common factor here, right? 5, right? 5 squared. So you take this out. 3 squared plus 4 squared is 5. So 5 squared is 25. All right. So that is yeah, right. You can also get it from the first equation. I think z equals y plus 9. I forgot. Yeah, z equals y plus 9. So y is already know that it's 16. 9, so it's 25. Okay, that's much quicker. All right. Yeah, good job. There we go. Thank you for posting answers here. Okay. Now, if I classify this problem, the difficult level is hard. Then the next one will be very hard. Okay, one level above. So we still have the same right triangle. Okay, so this is a 15. This is 39. I can even give you the other side, right? The other side is what? You know, we already did the calculation. The other side is 36. Fine, 36. Okay. Sometimes you give us 3 sides without telling you it's right triangle. This time I'm going to I'm drawing the line, but these 2 angles are the same. Bisect the angle. That's a B. Okay. So this is a B and a C and a. Okay. Still the same question here. I want to find the AD, DC, and BD. Right? If I'm able to find the 2 of them, you can get the rest of them, right? Okay. This is the X, Y, and the Z. Right. So I hope some of you can figure it out, but you have to use the property bisect. You know, right now you're not given the equation that Z equals Y plus 9. You are given different type of equations here. Right. But you have to use a property. Those 2 angles are equal. Right. So try and work. This is a much harder. I hope some of you can figure it out. I give you 1 minute to think about. Right. You may have to draw addition lines. That's my hint. Okay. Anyways, ideas? right, so let's try. Okay, so this is a difficult. I have to say that it's from math class. So how do I do that? I draw addition line. Oops. Just a second. X equals Y. You think we have to prove it. Of course, if we can show that X equals 18, then X equals Y, right? But that's not the middle point. The angle, okay, the angle here bisect, right? But that's guaranteed. This is you know, also divided the BC into two equal parts. Okay. So what I'm going to do is, where's my pen? Hold on. What happened to my pen? All right. What I'm going to do is I'm drawing the line. Okay. So this is right angle. I'm going to call it A, B, C, D, E, H. And then if you do not use the bisect angle, you know, do not use the angle property, then you probably cannot solve the problem. So you look at these two triangles. My question is, are there these two triangles are congruent or not? Okay, these two triangles are congruent or not? The triangle ABD is exactly equal to the triangle AED. Okay. 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 So if that is true, then this let's go back to, let's look at this triangle again. Okay, so this is X, this is a 15, this is a Z, this is a 39, and here's X. Okay, so immediately this is, you know, this is a 15, right? Because it's triangle identity. And then this will be 39 minus 15. So that'll be 24. Okay, right? 24, no, I did not scare that. You know, I did not draw the perfect picture, but this is a, yeah, 39 minus 15, right? It's going to be 24. Okay. Okay, and this is a Y, right? So now we have a bunch of right triangles. So we can apply the Pythagorean theorem to this problem. Okay. Okay, so X plus Y is going to be 36. That's first thing. X squared plus 24 squared equals Y squared, right? Applying the Pythagorean theory to that triangle. Okay. Then I also applying the Pythagorean theory to this triangle, right? And the 15 squared plus X squared should be equal to Z squared. Wow, we have lots of yeah. So we have we do have three equations, and you can solve that. Okay. I think you find X. You find the X and the Y from the first two equations. So equation 1, equation 2. Okay, so from equation 1, equation 2, Y squared equal, okay, that's by equation 2. And then this is where y minus x, y plus x equals 24 squared. Okay. So y plus x is already know that 36. So this is 36. That's why going 24 squared over 36. I hope this is going to be a this is going to be a integer. Okay, 24 is going to be 4 times 6, right? So 6 squared is gone. 6 squared 36. So it's 4 squared 16. So y minus x is 16. Y minus x is 16. And as you see that y plus x is 36, y minus x is 16. Okay. Right? So they're not equal, right? Okay. So add them together, 2y equals, right, 52. So y 52 divided by 2, right? That'll be 26. Okay. So once you get that, then you can get x. X is 10. So then you get a z. Let's skip that step. Yeah. Okay. So remember, okay, the difficult part is that you draw addition line, and you recognize this two triangles are congruent. Okay. These two triangles congruent. Then you write down the equations using the Pythagorean theory. Then you solve the problem. Okay. So the algebraic problem, it's a similar. I don't think it's more complicated. Okay. Anyway, you can solve it. Okay. Although here I have two equations, quadratic equations. Okay. So let's go back to the problem. Right. Ask yourself why you didn't get it at the very beginning. I think the difficult part is draw addition line, how to use the angle here. Equals. Those two angles are equal, so you have to use it. You cannot see, I did not draw the graph perfectly, so I cannot guarantee it. I know D is the middle point. Actually, D is not the middle point. Okay. Actually, D is not the middle point. Well, I'm going to relax a little bit, and we are going to take a look at simpler problem. Okay, using Pythagorean theory. Okay, the length of the diagonal rectangle. I'm going to use this is a rectangle. So A, B, C, D equals half of the pyramid. Okay. So this is a D. Okay. Okay. This is the length, the D. Okay. So we are given some information about the length of the diagonal. Equals half the pyramid, okay, less than minus 4/5 of the width. Okay. We don't know the dimension. Okay. Find the ratio of the length of the shorter side to the length of its longer side. Find the ratio with the length of the rectangle. Okay. Okay. That should be not that complicated. So can you solve it? Okay. So the length of the diagonal, right? So if this side I call the L, this called L, this W, right? So let's write down the equation B equals the half of the parameter is L plus W, right? Minus 4/5 of the width. Okay, that's a given information. Okay, I give you that. So can you find W over find the W over L? Okay. Okay, this is a geometric problem. Right, please let me know if you get it. Grant, are you working on the problem? I haven't heard you for a long time. If you get answers, get some ideas, please share with us. All right, anyone has answers? Of course, that equation is not enough. You have right. You have to use the properties. This is a rectangle, not a parallelogram, right? It's a rectangle. It's not a parallelogram. I don't think you can find the width. The reason is this property probably remain unchanged if you scale the rectangle, right? Because we say the length of the diagonal, right, equals L plus W. So if you double the length, double the width, you double the length of the diagonal. So I think you cannot get a specific value for W. However, the ratio, okay, probably can be determined. Right. So the relationship between D and the length of widths by the Pythagorean theory, this is going to square root of L squared plus W squared. That's all you need. Okay. So now you have L squared plus W squared has L plus 1/5 W. Okay. Then from here, you square on both sides. Okay. So you get L squared plus 2/5 LW plus 1 over 25w squared. Okay. So L squared is gone, that's okay. And then what? Then you get w squared equals 2 over 5 LW plus 1 over 25W squared. I think we can divide W on both sides, right? So you get W, so you get a linear term. Okay. So I'm going to move this to the left-hand side. So what I get is 24 over 25W equals 2 over 5L. So therefore, W over L equals 2 over 5 times, and divide by this is 25 over 24. Okay, then you simplify it. So it's 5 over 12. Right, that's the width. That's a ratio. That's a ratio, 5 to 12. You should write W over L, right? Looks like Erica got it. Erica got it. Okay. Good. Now I'm going to look at, right now I'm going to look at regular orthogon. Now what is orthogon? Was sides of length 4 feet. Okay, regular means all the sides are equal. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a octagon. Okay, I'm trying to find all the information I need. Okay, question is, what is the area of this? Okay, then next one, I choose a middle point, or choose this middle point, okay? Choose those middle points, I'm pretty sure I'm going to get, yeah, this is a middle point. Okay, middle point. To form a quadrilateral. Okay. Yeah. And I want to know how big of this quadrilateral. Okay, so this is the middle point, and the connecting them. Okay. If the middle point of alternate sides, okay, are joined to form a quadrilateral. Okay. What is the area of a quadrilateral? Okay, so that's the second question. So that's 2 questions here. Are we able to find, yeah. Yeah, how do you solve this problem, right? Yeah, let me draw this again. Picture, I'm not going to destroy the original one. Okay, so connect those 2 points. This is a 4, right? And I'm going to call it A because this is going to be the edge length. I think this quadrilateral is a square, clear, right? Quadrilateral is square. So what is A? Can you figure it out? If you know the A, and you probably can get the area of the quadrilateral first. Otherwise, yeah, it's not easy to find the area of the octagon. How do you find the area of octagon? It consists of many right angles, right? There's a third question. Maybe you want to try is you want to find this length. Okay, I call the R, right? The third question is find the R. Okay, so you get all the information you need. This is the center. Okay. Right. So if you draw the circle around that point, then you should get a circle. And what is radial circle, right? All right. So as an engineer, right, sometimes you need to do this calculation. You know, you have a part cross section looks like that, and you want to measure it, right? Before you measure it, you want to see, can you, if you only know the side, sometimes even you cannot cut it, right? You only can measure the edge length. Can you determine the area of the cross section? If you draw the square there, can you determine the area of the square, right? I still give you, no, I don't have much time left, right? So I'm not going to, yeah. So the idea is that this is a 45 degree. This is 45 degrees. So let's take a look at this piece. 45 degrees, 45 degrees. So this is a 4, right? And this is a 2, right? So you can tell what is H here, okay? So this is a H, and this is also H because it's a isosceles right triangle. So the H is going to be 2 over square root 2, right? So which is square root 2, clear? It's not that complicated. So then A is going to be 4 plus 2H. So it's 4 plus 2 square root 2. So the answer the second question first. The A is the area is A squared, 4 plus 2 square root 2 squared. Okay, so you can simplify it. What is going to be, right? It's going to be, and I'll take a 2 out, so it's a 4. 2 plus square root 2 squared, that's squared. Okay, 4 plus 4 square root 2 plus 2. Okay, so it's 4, 6 plus, okay. You can multiply this out, 24, 16 square root 2. So that is the answer of the area of the square. This, in order to find the area of, of the octagon, I just need to find the area of this piece, right? And the area of this piece is going to be, here's a 4, here's a 4 plus 2 square root 2, and this height h is a square root 2, right? It's a trapezoid. So it's half of 4 plus 2 square root 2 times square root 2. So let's do the calculation. Okay, it's going to be 4 plus square root 2, 8, right, divided by 2, right? Multiply by 2, so that's 4 square root 2 plus 2. So that is the area of that section. Octagon, octagon, right? You have 4 pieces here. This is right. So the total area is going to be the area of the square inside. We already get it, right? So the area square plus 4 times the area of this, right? The area of the square plus 4 times the area of the trapezoid. Okay, so it's going to be, right? You have 24, 16, square root 2, and here 4. So let's multiply this out. All right. So it's 32 plus 32 square root 2. It's 32, 1 plus square root 2. All right. All right. Yeah. So now the question, last question, is what is the size of this? What is the size? This is an isosceles triangle, right? This is R, here's a 4, right? How can I find out? Yeah, Erica, how can you find out? I'll give you a little bit time to think about. You find the total area of octagon, you find the area of the square, right? Are you able to find the R? Anyone have ideas to find the area of R based on the information we already got? To find the R? Hey, so you have to find the area of triangle ABC. So area of the triangle ABC is going to be the area of the whole octagon divided by 8 because they're all equal, the triangles, right? So it's 4 times 1 plus square root 2. Okay. Now once you get that, okay, you probably can get. Can we get there? Can we get the radius? Then you can get the height because this area is going to be half of 4 times height, right? So you can get height. That's another way to calculate area. So h is going to be 2 of this. Then apply the Pythagorean theory. Okay, now you're applying the Pythagorean theory. I is going to be, right? So this is a triangle, right? You have h, that's 2, here's r, right? I is going to be, r squared is going to be 2 squared plus h squared. Okay, so you do get lots of information here. It's a 2, here's a 4, 1 plus square root 2 square, right? Yeah, let's finish the computation. Okay, I'm going to get 4 plus 4, 3 plus 2 square root 2, 12 plus 4, 16, 8 to square root 2. Okay. Finally, I is going to be square root of 16 plus 8 to square root 2. Whoa, that's a very strange number, right? Unfortunately, it's a number, right? I cannot make it like a square of something. Okay, so this is the answer. Okay, we got all the information about this octagon, right? All you need, all the dimensions, you find out. This is a very good problem. It involves Pythagorean theory. It is also involves the tricks we use how to find the height using the area. Because this is trick, we already know that, right? How do you find the, and this is a similar trick, you know, how do we find the, if you have a 3, here's a 4 and a 5, right? How do you find the h? The easiest way to find this h, the height, is use the area. 3 times 4, that's the area, and also equal to 5 times h. So h is going to be 12 over 5. That's the easiest way to find the height. We call it using the area to find the height. Okay, sometimes, yeah, this is a trick also used for that problem. And 45 degrees also used, right? Yeah, and right, so, yeah, right, we got all the information we need. Great. All right, let's take a look at another problem. It's about triangle, okay? We have a triangle, A, B, C, and I draw the line, speaking of this, right? So what I know is AB is 10, BC, AB is 10, BC is going to be 21. So AB is 10, and the AC equals 17. And I want to find the ratio of the parameter of the triangle ABD to the parameter of triangle ADC. Okay, find the ratios, the parameter of a triangle ABD and of the parameter of the triangle ADC. Okay. Now, of course, if we can find all the information AD, BD, and DC, then you solve the problem, right? Yeah. What is the quickest way to solve the problem? All right. Now, clearly, this is not a right triangle. So 10 squared plus 17 squared is not going to be 21 squared. So it's not right triangle. Okay. The quick way, the quick way to do is if we are able to make, if you can recognize this consists of two special right triangle, then you solve the problem. Okay. If you are able to see, okay, 10 square, and then I also use 8 square plus 15 square equals 17 square, and then I think 6 plus 15 equals 21. If you know those relationships, then you already solved the problem. Okay. Okay. This is a shared side AD. Okay. Yeah. So if this is 8, this is 16, this is a 15. If we can recognize this, then you solve the problem. Okay. So the answer is 3 over. The answer will be, the parameter here is 1 plus 6 plus 8, otherwise 8 plus 15 plus 17, add them together. Okay. So those are the special triangles. Now, if you cannot see that, what are you going to do? Okay, this is a 10, here's a 17, right? And here's 21. If you cannot see that, okay, then what you should do, you have to find the h, you have to find the x, you have to find the y. So you write all the equations you're going to have. X plus y equals 21. X squared plus h squared equals 10 squared. and h squared plus y squared equals 17 squared. So you have 3 unknowns, 3 equations. Then you find x, y, and h. You can do that, okay? So I'm not going to talk about this method, but you can, this is a standard way, just like solving quadratic equation. You can, if you can quickly factor it, you get 2 roots. But if you don't, then if you cannot, then use the quadratic formula. It involves more computation, but you can solve this, right? So you can, you can find the x, y, z, then you solve it. You can solve the problem. Okay. I'm not, you know how to solve this equation, right? You have 3 equations, 2 quadratic. So I'm going to discuss another problem. Question here is how many distinct isosceles triangles that having sides of integrals and the parameters are fixed. Okay. So you have a triangle, right? And here's A and B and C. Now actually it's a quadrant, so isosceles triangle, right? So you have you draw the line, okay? And this end here's B and B, okay? So A, B are integer, okay? And A plus B equals 93, okay? So that's it. We're trying to find all possible triangles. In order to make them a triangle, you have to use this property. They're triangles. They're not arbitrary 3 numbers. Otherwise, you have more solutions. Okay. So the triangle inequality must be satisfied. So A must be less than B plus B, and the B must be less than A plus B. Another way is also B plus. So those 3 triangles only equivalent to 2. A is less than 2B. Not only one equation you need, okay? Because other 2 equations are satisfied automatically as long as they're positive integers, right? Positive integers. B is always less than A plus B. All right, so this is an inequality, and I know that A plus 2B equals 93. A is less than 2B, right? And I'm trying to find those integers. All right. First, I can figure out what is the possible value for A and B. Okay, so A is greater than, right? Yeah, using this, using this, B is greater than, B is greater than 2A, 2B is greater than A. So be A plus A less than A plus 2B, right? Equals 93. So 2A is less than 93. A is less than 93 divided by 2. It's going to be 46.5. Yeah, 46.5. So 46.5, and then A could be, I think A could be, yeah, right? So A could be, but point, see, use that, then B, A cannot be always, A must be other numbers, I think, because 2B is even, right? So A could be 1, 2, right? 1, 2, 3, 4, all the way to 46. But the corresponding B is going to be 93 minus A divided by 2. So that clearly A must be other numbers. Okay, so you list all of them. It's 1, 3, and 5, all the way to 45. Okay, so how many of them, right? You just count the other numbers. Okay, to count the other numbers, yeah, if you to count the other numbers, then I think it's 23, right? So how can I express other numbers? Other numbers I can express in the following way: 2k minus 1. So k started from 1, you get 1, 2, right? So 2k minus 1 equals 45. So 2k is 46, k is going to be 23. So the last one is 23. When k equals 23, you get 45. So that's why you have a 23 answers, distinct isosceles triangles. The answer is 23. Okay. So here we needed to know the triangle in coordinates for triangle if you're given 3 numbers. Okay. Yeah. So that's all for today's class, geometry problems. Maybe we are going to have another geometry class before then.